Right, this next section says to evaluate the integrals using trigonometric substitution. So I know on these ones I'm going to have to set up in my triangle. So that's what I'm going to do first. I'm going to set up my triangle. I will know based on this that this is my c squared, so the hypotenuse will be 3x, and then one of the sides will be the square root of 9x squared minus 1, and the other side will be 1. Theta there. Alrighty, so first of all, if I'm solving for x, I'm going to use secant because I have opposite and hypotenuse. So I'm going to have the secant of theta is equal to 3x over 1. And I'm trying to solve this for x, so actually all I need to do is just divide both sides by 3. So x will equal 1/3 secant theta, which means dx will equal 1/3 secant theta tangent theta. Alrighty, and then from here we will have, solving for the square root, we'll have, oh, that was actually adjacent, I apologize for that. And we'll have opposite, so opposite over adjacent, we'll be using tangent. So the tangent of theta is equal to the square root of 9x squared minus 1 over 1. So that just means the square root of 9x squared minus 1 is equal to tangent theta. All right, we are ready to go ahead and substitute. So first of all, we'll substitute for dx, which is 1/3 secant theta tangent theta, and then over the square root is equal to tangent theta. So my tangent thetas cancel. I am left with, I'll put the 1/3 on the outside, I'm left with secant theta, and then from here, and actually technically we should have a d theta there. All right, so anyway, we're left with secant theta. I know that the integral of secant theta is ln, so we're going to have 1/3 ln, absolute value of secant theta plus tangent theta. And then from here we do need to just substitute back in what we know. So we're going to have 1/3 ln. Secant theta we already found out was equal to 3x, and then plus tangent we found out was equal to the square root of 9x squared minus 1. And then we'll add our plus c, and that problem is done. All right, problem 12. We've got the integral of x over 9 minus x squared to the 3/2 dx. I'm going to convert this to a square root problem first. So this really is the square root of 9 minus x squared to the 3rd power. And now we're ready to set up our triangle. So if I set up my triangle, theta, our hypotenuse will be 3. One of our sides will be x. We'll just have that be the vertical side. And then we've got the square root of 9 minus x squared. So then from here, I'm ready to set up that triangle. I'm going to start with x. I have opposite and hypotenuse, so I'm going to be using sine. So I'll have the sine of theta is equal to x over 3. If I cross multiply, I'll get x is equal to 3 sine theta. The derivative, dx, will be 3 cosine theta d theta. Alrighty, solving for the square root, I have the adjacent and hypotenuse, so I'll be using cosine. So the cosine of theta is equal to the square root of 9 minus x squared over 3. And then cross multiplying, I'll get the square root of 9 minus x squared is equal to 3 cosine theta. Alright, so now let's go up and substitute. Alright, we've got an x going on, which is 3 sine theta. Then the square root of 9 minus x squared is equal to 3 cosine theta, but we're going to be cubing that. And then we still do have our dx. Do not forget to plug in dx, which is 3 cosine theta d theta. Alrighty, let's write down what we have here now. If I combine up top, I'll have 9 sine theta cosine theta. And then on the bottom, I'll have 27 cosine cubed theta. Alrighty, so now 9/27 is 1/3. I'm going to bring that to the outside. And then if I simplify, I'll have sine of theta over cosine squared theta. And I notice at this point I can do a u substitution. I'm going to let u equal the cosine, which means du is going to be negative sine theta. So I'm missing a negative. So there we go. So now I have negative 1/3 du over u squared, which is the same thing as u to the negative 2. And so if I do that, I'll have negative 1/3 times the integral of u to the negative 2 would be u to the negative 1 times negative 1. So this will be 1/3 u to the negative 1, which is 1 over 3u. 1 over 3u, which is 1 over 3 cosine theta. And if 1 over cosine is equivalent to secant, so we actually have 1/3 secant theta as my answer, and then we just need to plug my secant theta back into the problem. So secant theta was, we didn't find secant theta, but we certainly can. So we have 1/3 times secant theta would be 1 over cosine. It's going to be adjacent, hypotenuse over adjacent. So it's going to be 3 over the square root of 9 minus x squared. My 3's are going to cancel. So I will be left with 1 over the square root of 9 minus x squared plus c.